Hello, Algebra 1 students. This lesson will be about Chapter 1.2. The topic is exponents and powers. This topic is in some ways a review for you, I know, but let's get started anyway. Let's start with the vocabulary. There are three terms that I want to make sure that you're clear on. Let's talk about each of them individually. Exponent, first of all. The exponent is only this number up here, the 6. And that 6, as we've talked about before, that exponent applies only to the thing it's next to, immediately next to, and that thing it's next to is called the base. The base is at the bottom of this whole thing here, and maybe it makes sense to you that it's at the bottom and called base, because after all, the base of a mountain, for example, is the bottom of a mountain. That whole thing I keep referring to is the power, or a power. Often I hear people refer to this as an exponent, but only this number up here is the exponent. The whole thing is a power. All right, let's talk about meanings. Base 4, exponent 6. What that means is that I have a string of 4s being multiplied by each other. How many are in that string? Well, the number in the exponent tells me there are 6 of them. And in fact, the reason we use powers, the reason we talk about exponential form, is so that we can have a shorthand so we don't have to write something this long. Now, writing 6 of these 4s is not so bad, but imagine if you had to write that many 4s being multiplied by each other. You would like to have a shorthand. In fact, it took me a while just to cut and paste all of these in place. I think if you add all of these up, you'll find there are 50 of these 4s, and it's the same thing as 4 to the 50th, or 4 to the 50th power. Well, speaking of that wording, I'm going to come to wording in just a minute, but let's make sure that we're clear first on exponential form and how it matches to meaning. So this thing, trying not to use words at this point, matches this meaning, and similarly this thing matches that meaning. But we have to use words, don't we? So that first, A, we would say 10 to the first power. B, we would say 4 to the second power. We could also say 4 squared. For the third one, for C, we could say 5 to the third power. We could also say 5 cubed. And for that last one there, we could say 7 to the 6th power. And that's all that we would say. What about this last one of all, though, here? Even before we get to the wording, what does it mean when you have a base of x and an exponent of n? Well, if you don't know what the exponent is, well, go ahead and stop and think for a second, and you decide, and then I'll uncover this. Okay, I'm going to assume that if you needed more time, you hit the pause button. And so now you're back if you did hit that pause button. The meaning is, The meaning is this. It means that we've got a string of x's and we don't know how long it is. So we might put in dots, an ellipse as it's called in grammar, and it means and so on. We don't know how many x's there are. There's a string of them. Now, how would we say that? What would the words be for that? It's x to the nth power. What if you actually had a value to plug in for n, and you will later? Let's say you had to plug in 4 for n. Well, that would mean you had x to the 4th power, or the exponent was 4. And its meaning would be a string of 4 x's. So ignoring what we have to the right of those dots, it would be this. X times x times x times x would be x to the 4th, of course. Your turn now. I've cut and pasted problems from a textbook. I happened to pick number 1 and then number 3 and then number 7 and so on from that book. In each case, what I did was I took either the wording or the meaning, and now I want you to write it in exponential form. So when you're ready, go ahead and do these. Hit the pause button. And when you come back, I'll give you the answers. Okay, I'm going to assume that you did that. Here are the answers for the first 3. Please come into class if you have different answers than these, if you want to talk about why these are the correct answers. But what about this 4th one? 3x times 3x. There actually are several different ways that would be correct ways to write that in exponential form. One of them would be 3x in parentheses all of that squared. Or you might have rearranged the order of these numbers, and you might have written 3 times 3 times x times x. Notice I haven't highlighted that in yellow because I don't think that's finished. You've written this kind of in the form that we called meaning before, but I don't think it's completely simplified. But you might have gone the next step and multiplied the 3 times the 3, gotten 9, the x times the x, gotten x squared, and, or even before that, 3 squared x squared would have been fine. Or like I'd said, 9x squared would have been fine. Any of those 3 in yellow is perfectly acceptable as an answer. Here's one that's not. Here's one that's wrong. 3x squared. And I see this all the time in Algebra 1 and Algebra 2 work by students. This is clearly not the same as that, but it looks so much like that that students get confused. What's different here? Well, in this case, we're saying we've got 3 times 3 and x times x. And that's actually what we did have. Over here, we're just saying that we have x times x, but only a single 3. Okay, example 2 out of the textbook. Let's say I told you that x is 5, and I asked you to evaluate x cubed. Well, the first thing you would do, like the textbook has, is you would plug 5 in place of x and say x cubed is the same now as 5 cubed. Then you might write out the meaning and say that it's equal to 5 times 5 times 5. And then whether you used a calculator, or I would suggest you should be able to do this with pencil and paper, you would find the answer 125. Okay, your turn. 2 more problems taken from that same book. Go ahead, hit the pause button, and when you come back, I'll show you the answers for these. Okay, I'm going to assume you did that. I'm going to jump straight, to the answers. The answer for 20 is 100. The answer for 22 is 5. But let's see why. A squared became 10 squared. Well, 10 squared is 10 times 10, which is 100. When I plugged 3 in for y, I got 14 minus 3 squared. Now remember a couple of things we've learned. First of all, we've learned that exponents only apply to what they're next to. Second of all, we've learned from our rules of PEMDAS that we need to deal with an exponential operation before we do subtraction. So if I've got to do this exponent first, this power first, 3 squared is 9. So I've got 14 minus 9. And 14 minus 9 is 5. Don't hesitate to come into class if you have questions about either of those. Now I'm going to come back to more of the textbook examples in a few slides, but first I want to talk about something. Notice we said this could be called 5 to the second, but we could also say 5 squared. And this could be called 5 to the third, but we could also say 5 cubed. But what about this one? We can only say 5 to the fourth. Why don't we have another name for that? Well, the textbook answers this, but kind of in the fine print. You have to look carefully, but if you notice this sentence, it's very useful, and I want to draw your attention to it. The word squared and the word cubed come straight from formulas. From the formula for the area of a square and the formula for the volume of a cube. And here's the picture that goes with that statement. The area of a square is equal to the measure of the side times the measure of the side, or side times side, which in other words is side to the second power, or, well, side squared. Similarly, side times side times side is the volume of a cube. Well, side times side times side is side to the third power, or side cubed. So, side squared, side cubed, we don't have a word like that for a fourth dimension because we live in 3 dimensions, and that's as far as we go in those names. But let's talk about applying these. On the left, I've gone ahead and done the calculations if the side of the square were 1 or 2 or 3, and I figured out what the area would be. I want you to do the same thing for the volume of a cube. If the side were 1, and then if the side were 2, and then if the side were 3. Go ahead and hit the pause button again. Okay, I'm going to assume that you did that. And here are the answers you should have found. 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. We can talk about this more in class. I would like to call your attention to the fact that the units for area, because area is measured, it's a square often, and it's measured, remember, in side times side type units, is often referred to with square in its name, such as square feet or feet squared. Similarly, the volume of something is measured often with the word cube in the name. Cubic centimeters comes to mind, cubic feet, cubic yards, and so on. Now, for example 3 in your textbook, I haven't used the exact same example. Instead, I've made a slight modification. So you can compare what work you do here in the video to the actual example 3 in the book. I've got 4 different problems for you to work with that all are very similar, but there are a couple of differences, primarily about where the parentheses are placed and where the exponent is placed. I'll do the first one for you. Remember, PEMDAS tells me to do what's inside parens first, so that 2 plus 3 becomes 5, and now I've got 5 squared, which becomes 25. Hit the pause button and solve the other 3 yourself. Okay, I'm going to assume that you did that and you're back now. Here are the answers to the other 3. Whoops, no, here they are. And in the interest of time, I'm not going to talk through each of these 3, but come and ask me if you have any questions about why those are the correct answers. Example 4, once again, I've made a slight modification to the example that's in the book. In this case, I've compared 4x cubed with something that looks a lot like it, but in this case, there are parens around the 4x. Both cases, x is 2. You're going to turn out to find different answers. Well, as I say here, example 4 is different from the previous examples because you've got a variable and a coefficient. We haven't talked about coefficients yet, but that coefficient is that number, in this case 4, that's being multiplied times the x. And we just want to see how combining a number and a variable in the problem and an exponent makes things any different. Well, the primary way that it makes things different depends on whether or not there are parens involved. So let's look at these 2. On the left, if I plug in 2, I plug it in for x and I've got 4 times 2 cubed. On the right, the 2 goes in the parens with the 4. I've got to multiply that first. So I've got 4 times 2, or 8 cubed. So notice that. On the right, I've got 8 cubed. On the left, the meaning, after all, of 2 cubed is 2 times 2 times 2. So I've got 4 times that. Notice what the calculations turn out to be, though. On the left, I end up with 32. On the right, something very different, 512. Come in and talk with me if you don't see how these are calculated. Do hit the pause button if you want at any point and look it over more carefully to make sure you understand. Examples 5 and 6. Well, example 5 we've actually covered already earlier. Example 5 is the story about squared and cubed. Example 6 we'll go over in class. There is one other thing, though, that I do want to make sure we cover, and that's talking about using a calculator to make calculations. Let's go back. This calculation over here, I want to make sure you know how to do that depending on what type of calculator you have. So let's say you have a very simple calculator like this. It turns out that I've looked at my phone, and my phone has even fewer buttons than these. It doesn't even have a square root button. But neither of these calculators has an exponent on it. So to do 8 to the 3rd power, or 8 cubed, I would have to multiply it out. 8 times 8 times 8. I would literally hit 8 times 8 times 8 and get my answer, but I would still get the same answer, 512. This calculator with more functions to it, I could go straight to this point. It turns out 8 cubed is possible for me. I would literally hit 8, and there's a button here, x cubed. So if I just hit 8 and that button, the calculator would tell me the answer, 512. Third type. This is a graphing calculator like the one I have. In this case, I've got to do something completely different. There is a squared exponent, but there's no cubed exponent on here. So I've got to do 8 up arrow 3. I hit 8, and then that up arrow button, and then 3, and then I hit enter. And that's going to give me the 512. So what you have to do depends on your calculator. Here's your homework. Come into class with that, and we'll talk tomorrow.